Hi, this is Connor from Kingwood, and you found Mr. Ford's Guide to the A+ exam, How to be a Computer Technician.
Hi, and welcome to Mr. Ford's Guide to the A+ exam, How to be a Computer Technician. This is episode 10. That's right, episode 10. We're in the double digits. How cool is that? In this presentation, we're going to cover what is parallel, what is serial, what are bits, what are bytes, some of the stuff you need to know for the A+ exam, and only for the A+ exam, and others that you actually need to know for both as a technician as well as future classes and future IT careers. So let's get going here. How do you connect a camera or a printer or a USB microphone to a computer? Well, you connect it through a port. You connect it to a connection. All these things that you attach to a computer are called peripheral devices. Some might make the argument that anything that you attach to a computer, whether it's internal or external, can be considered a peripheral because it's not actually part of the motherboard or CPU. I'm not worried about splitting hairs that much. Just understand that anything you connect to a computer is considered a peripheral device, whether it be a keyboard, a monitor, a mouse, joystick, anything is considered a peripheral device. Just because you connect a device to a computer doesn't mean it knows how to deal with it. Doesn't even mean it knows it's there. What has to happen is the device has to work with the computer to establish how it's going to communicate back and forth. So it establishes something called an I/O address. Now, before we get into all technical, goofy gobbledygook, let's break this down into first day of classes. Now, you might be a high school student, you might be a college student, you might be a professional out there in the work world. But we've all had to go to school at one point in time or the other. When you went to school, you knew where the location of the school was. You either had a map or you'd been there before, but you knew where the school was. And you had a schedule, so you knew what classroom you were going to. You would take this map of where the school was, and you would take your schedule of classroom you're in, and you would find where you were supposed to go. The computer is kind of the same way. It has a system where it knows what's attached where, and this is called I/O addressing. We could go into more detail on this, but it's really pointless because we don't need to know that much detail. If you are an engineer or you're a computer engineer or you're into this stuff, then you can find more information about it. But for our purposes, know that when a component attaches to a computer, we have to establish an I/O address, an input-output address, which will tell the computer where this thing's located at. We will discuss this in further detail later on, but for right now, let's just leave it at the basics. Input means bringing information into a computer. For example, I'm using a USB microphone right now to talk to my computer. The computer is taking my voice and converting it into digital format that the computer can process and use. The microphone in this case is an input device. It is bringing information outside the computer into the computer. Vice versa, you're listening to my voice, and so you are listening to audio output that the computer is processing. Remember, it's got to use bits because my voice is just stored as data bits in your computer. It is taking these bits of information, converting them to sound waves, and letting your ears hear them. Your speakers are an output device. You're listening to my voice. That's output. So input going in, output going out. Real complicated stuff here, okay? All the standard ports on a PC have been given default addresses. They all have a default number that they know is their opening. These numbers can be changed. Why you'd want to change them now, I have no idea. Back in the day, way back in the day, you would actually have to change these numbers sometimes because you would have a conflict of devices. You had device conflicts. If, for example, and I remember this back, when I had a 486, this was before Pentium, I was running Windows 3.1 and DOS. We had a computer that had a sound card and we had a printer. If I wanted to use my sound card, I would have to turn off my printer. I'd actually have to go into the setup routines of that computer and disable the printer so I could free up those resources, free up that information so my sound card could use them. I am happy to say that nowadays, this is not a concern. Computers can handle a lot more devices, so you don't have to worry about turning off a video card, or not the video card, you can be able to see anything, but turning off a sound card or turning off a printer card or printer so you can use some other device. The good news about these ports that we're going to talk about is that while there is a whole bunch of devices that you can plug in, think about USB devices. I've seen just a whole bunch of different USB devices, mice, keyboards, beverage warmers. You can actually buy something that you can put your coffee cup on and it keeps it warm. I've seen air conditioning units that you can plug in. I've seen turntables and and USB snowmen. So think about all the different devices you can plug into a computer now. Luckily and very happily, these devices have standardized ports. And what's interesting, and this is kind of a bizarre idea to think about, but it's true. The standards that we have on computers were not made by a government agency. It's not like a government agency came out and said, this is how we shall connect to computers. What happens is companies, businesses, battle it out.
Give them nothing, but take from them everything.
The first standard for computers would be the serial port. Now we're talking about standards as far as connections go, not the internal components. We're talking about external connections. The first one was the serial port, and this is pretty much the granddaddy of all connections. It was based on the RS-232 standard, which means absolutely nothing in the real world, but you might hear it tossed around. So the RS-232 does mean the serial port standard. It sends 1 bit of information at a time. It can either be a 9-pin or 25-pin connection. The 25-pin was really, really, really old. They then switched all serial ports to the 9-pin. But again, even that is kind of old. So the 25-pin was super duper old, and the 9-pin is just ancient. The port will be male. The port being the connection part that would be on the back of the computer would be male. It would have pins sticking out, which means that the serial connection, the cable that you would connect to the computer, had to have female ports, meaning it would have holes that the plugs would fit into. Most PCs, at least 5 years ago or so, would have at least a 9-pin serial port. Currently, we have legacy-free devices, which we're moving away from a lot of this old stuff. Legacy-free, you're going to hear that term battered around a lot in the IT industry. Legacy-free means that we're moving away from the old junk that just shouldn't be on computers anymore. Something you're going to discover when talking about Windows, Microsoft, and computers, AMD, Intel, is that there's always been a kind of a weight around their legs as far as progressing. They've always had to make sure that whatever new things they came up with were compatible with the old stuff. They had to be backwards compatible. Legacy-free devices means no floppy drive, no serial port, no old stuff. The connections on the back of the computer are called DB9 or DB25. Obviously, the 9 or 25 stands for the pins or contacts. The DB stands for data bus. Here's something you need to know, not so much for the real-world application, but definitely for a possible A+ question. Serial cables, meaning the cables that are serial, can only go up to 50 feet in length. The old-fashioned serial cables, 50 feet was their maximum length. What's the practical application of this? Well, not really much, because you're not going to go to the store and buy a 70-foot serial cable. They're not going to sell these to you because nobody makes 70-foot serial cables because they don't work past 50 feet. But you got to know it for the exam. Serial ports can communicate in one of two ways. It can either communicate synchronously or asynchronously. Synchronously means that it talks and talks and talks, and even when it has nothing to say, it'll still talk. Kind of like this. And this is going to get annoying, and I apologize, but this is synchronous communication. Ready? Okay, let's go. Synchronous communication will blah, 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 continue to talk, blah, 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 even if it blah, 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 has nothing to say, blah, 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 because it doesn't want to blah, 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 stop, blah, 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 their communication pattern, blah, 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 blah. Take a breath. Asynchronous has a start and stop. It will say start and communicate, and then it will stop and let everybody else. So what asynchronous does is the following. Start. I am talking about asynchronous communication. Stop. Start. It does not speak unless it has something to say. And when it is done saying what it needs to say, it'll stop the message. Stop. That was asynchronous. So those are the two methods on which serial ports can communicate. Now here is something that makes you happy you're learning about computers now as opposed to 10 years ago. 10 years ago, you had to know about something called the UART, or the Universal Asynchronous Receiver and Transmitter. Even though you kind of have to know about it today, back in my day, we had to know about the different versions of the UART because as computers would get better and better and as components would get better and better, you would have different versions of the UART. And so you might attach a new serial device to an older computer and it wouldn't work because your UART was out of date. Luckily, we're past that. We don't have to worry about the UART except to know that a UART is the brains behind the serial port. In case you're asked, and it might show up, it might not, but just in case, the UART is the brains of a serial port. Its function is to turn parallel into serial information. That's its job. That's what it does. And luckily, that's all we have to know about the UART. Speaking of last, we have to know about the UART. This is pretty much it about serial ports. This technology is dead. We don't use serial connections anymore. And I'm going to give a caveat here, except for blah coming up soon. We don't use these old-fashioned serial ports. We don't use 9-pin. We don't use the other pin. We don't need them. They're old technology. They're legacy. Let them die in peace. Having said that, right now, some people are out there going, oh, you're wrong, you're wrong, you're wrong, you're wrong. Technically, yes and no. I hope that's clear enough for you. Maybe I should run for politics there. Yes, the serial ports are dead. The serial technology is not. But you just said, yeah, I know what I just said. USB, Firewire, PCI Express, serial ATA drives, hard drives, serial ATA CD-ROMs and DVDs are all serial devices. Serial is the way to transmit data of the future. This is how the new devices are working. They're all transmitting it serially because it's faster than parallel. Our next section is going to talk about bits and bytes. 1 bit, that's BIT, which is abbreviated with a small b, is nothing much. It's either an on signal or an off signal. It's either a 1 or a 0. 1 byte, B-Y-T-E, which is a capital B, equals 8 bits. 8 are the little guys, okay? Either 8's ons or 8 offs or any combination of those. 1 byte is a character. It is a letter. So let's say on your keyboard you push the letter J or K or A or F or whatever. That one character, that one bit of information, that one thing of information, shouldn't say bit, that gets confusing. That one piece of information is actually 1 byte of information. It's 1 B-Y-T-E. It takes 8 little bits, 8 little B's, to make 1 byte, to make 1 character. 1 kilobyte, big K, big B, equals 1,024 bytes. 1 megabyte equals 1,024 kilobytes. 1,024 is going to be a common number. So 1 kilobyte equals 1,024 bytes. 1 megabyte equals 1,024 kilobytes. 1 gigabyte equals 1,024 megabytes. And 1 terabyte, which is really nice for a hard drive, is 1,024 gigabytes. Let's say you have 2 gigs of RAM. You actually have 2,048 kilobytes of RAM. So 1,024 is actually the transfer. Now, unless you're going in for a seriously picky person, they're going to allow you to get away with the 24. But be careful, because the A+ might actually ask you that question. It might say 1 megabyte equals how many kilobytes, and it won't ask you as clear as that. They're going to ask you some contorted way where you have to know that 24 is at the end. Or they won't even ask you that. They're going to ask you 3 megabytes equals how many kilobytes. Something along those lines. So you have to know that the 1,024 is the base unit here. It's whatever 1,024 is to the next level. Bits have special names depending on your grouping. Now, we just talked about 1 bit and 8 bits being a byte, but there's other names for these as well. 4 bits is a nibble, and I'm not making this stuff up. 8 bits is a byte. 16 bits is a word. 32 bits is a double or long word. 64 bits is either a very long word, a paragraph, or a quad word. Know those. Not so much for the A+ exam, but you will run into these if you continue in the IT programs, into networking especially. Our next topic will be parallel ports. Parallel ports is another one of those dead and dying technologies that you need to know for the A+ exam and for the occasional very old computer. In fact, a couple of weeks ago, I was in a subway out here in Houston, and I noticed that the printer for the receipt actually had a parallel connection port. Well, that was kind of interesting and all, but for the most part, on personal computers, completely waste of a tangent there, wasn't it? On the modern PC, you're not going to see parallel ports because, for the most part, they were used for printers, and now we have USB for that. The parallel port is defined by the IEEE 1284. Now, what does this whole thing mean? What is the IEEE? The IEEE stands for Institute of Electronic and Electronic Engineers. At least that's what I think it is off the top of my head without having to do a all-inclusive Wikipedia search. What they are is they are a organization that helps define standards. And you're going to run into several different organizations that define standards as we go through the A+ course. But the IEEE in this case have decided that to be a parallel port, for computers to make parallel ports, they have to configure their computers to certain standards. What this allows is that it allows manufacturers of printers and other goodies to know what kind of connection they need to make so it works with the computer. In this case, it's the 1284 standard. Do you need to know this for the real life? No. Do you need to know this for the A+ exam? I would give a hesitant yes. And the reason why I would give a hesitant yes is because I don't think they're going to ask you any questions directly on the parallel port, but they will definitely ask you questions on FireWire IEEE 1394. So if you know that 1284 is for parallel ports, that is one less detractor, one less bad answer choice that will mess around with you. So know that the parallel port is the IEEE 1284. They have 25-pin female DB ports on the back of the PC. Remember, DB data bus and female being the holes in the back of the computer. So if you were to look at the back of a computer, you can tell if it has a parallel port if it has 25 pins in a D-shaped connection on the back of a computer, female. Currently, if you have one, they're currently like a pinkish color because of color standards, which we'll talk about in a different presentation. Serial ports are called COM ports. Parallel ports are often referred to as LPT ports. You might also hear a parallel port called a printer port. This is not technically correct, although it is commonly used. The reason why it's commonly used is because for years, the parallel port had basically one function in the consumer market, and that was for printers. And then scanners came along, but for the most part, printers left their mark early, and a lot of people call them printer ports. Again, they're technically called LPT ports and not printer ports. If we look at a parallel port cable, if we look at a cable that's a parallel cable, we're going to notice that both ends of the cable look different. The end that goes to the computer, the end that attaches to the computer, is going to be a DB, data bus, 25-pin male connector. It's going to be a male connector. It's going to have pins. The business end, the end that actually connects to your device, whether it be a printer or scanner, is going to be a 36-pin Centronics connector. Centronics, quick brief history here, a Centronics connector is named after the Centronics company that developed these. They came up with a very popular standard that people incorporated into their parallel ports for printers. The part that connects to the computer is a 25-pin male connector. The part that connects to your peripheral device, most likely a printer or scanner, is a 36-pin Centronics male connector. Here again is some worthless information you need to know for the A+ exam. The parallel cable should not exceed 15 feet in length. 15 feet is how long that you want this cable to be. You don't want to be any longer than 15 feet. Will you be able to buy a cable longer than 15 feet? Probably not. There have been 4 basic types of connections for parallel port. This, again, was important about 5 to 10 years ago, but currently it's taught as a passing by. We really don't cover it in too much detail. I'm going to mention it just in case you ever run into it. You kind of go, oh, I remember hearing about that, and then you can look it up on Wikipedia or whatever. The 4 types of connections that parallel ports used was the standard parallel port was the first one. It was the really old one. It was unidirectional. It sent information one way. So you would send a print job to your computer and it would print it up. You wouldn't know if you were low in ink. You wouldn't know if you were out of paper. You wouldn't get a confirmation of the job being done. It would just send it out and hopefully the printer got it. Then we have the bidirectional parallel port. This was the second, generation of the parallel printer port. What this would allow is actually two-way communication. In the case that maybe your printer ran out of paper, it would give you a notice. Or if you ran out of ink, it would give you a notice. It would give you some sort of, bleep, we're done. The enhanced parallel port was kind of like the bidirectional, except it was faster. And the enhanced capabilities port was even faster than the other 3. With the enhanced capabilities port, now think what's going on at this point in time. Originally, we had printers. You just sent the print job out, it printed, have a nice day, all that fun stuff. Printers got a little more complicated, a little bit more sophisticated. So then they could tell you how much ink they had left. They could tell you if they ran out of paper. And then we wound up with scanners. So we actually wanted information no longer going just to the printer, but we wanted information from that outside peripheral device to come into our computer. So with the enhanced capabilities port, we could now put scanners on our parallel port. Today, we have something better. Of course, we have FireWire and we have USB, which does a much better job than all of this. Again, this is pretty much dead technology. We're teaching it in passing. You might run into it out there in the field, so you need to be somewhat familiar with it. All right, well, that brings us to the conclusion of this introduction to connections and ports. In our next couple of presentations, we're going to talk about FireWire and USB, the stuff that's actually out there, the stuff that you need to know as a technician, the cool stuff, really. So we hope you're enjoying these videocasts and podcasts. As always, I welcome comments and suggestions to Mr. Ford at mrfordsclass.com. Also, if you'd like to give me a rating and give me some comments on the iTunes, I would greatly appreciate it. Until our next presentation, guys, have fun studying out there. Have a great one. Bye-bye.